There's the PowerPoint. Okay, so if I'm going to put it full screen, and if when I change it to that slide with the babies on, you don't see that, let me know. Okay, all right, let's see what we can get done today. We might not go the whole time today, actually, because there's some information here that I don't want to cram too much in for you. I want to give you a chance to think about it, and then we can talk some on Thursday about that, and we can finish this off. So on Thursday we will finish chapter 2 and start chapter 3. Okay, I think that's what I have set on the syllabus. Okay, so chapter 2 has a lot of historical information in it on theoretical approaches to for research and for teaching. And so I'm going to skim this quite thinly because I don't want you guys to get too bogged down in old history. I want you to really concentrate on that constraints theory that we started to talk about in chapter 1. Okay? So, I am going to change this slide. Did it change for you? Hello, hello?
The slide didn't change.
It didn't change? Poop.
No, it didn't.
What is going on here? Okay, let's do this differently then. Okay. I can do this. I can do this. We will stop sharing the screen and we will share a file, she says. Whew. This is my clicker won't work, so I'm going to have to keep running backwards and forwards to the mouse. Okay, here we go. Share now. Okay. Does that work? You can see the babies now.
Yes, we can.
Hurrah! Okay. All right. This just means that my clicker is not going to work and I'm going to have to keep running backwards and forwards to change the slide over. Okay. So, what we're looking at is when we're talking about motor development, we're really looking at what happens with these motor skills, all right, across the lifespan. So hopefully you've started to get a taste of that, especially in the lab, where we've been talking about different assessment tools, all right? So let's think about this from a family perspective so that we can really understand, kind of get the picture in our heads of what we're trying to achieve. So on the left, we have a newborn baby who's about 1 week old, all right? And let's say this is your niece, okay, or nephew, okay? And you go home to see your sibling and meet the new baby, okay? And it looks kind of like this, makes a lot of noise, right? It can't move. This baby cannot move voluntarily. So the movements that we see at this age are all involuntary, all right? And we're going to talk about those in a lot more detail in a couple of weeks. Okay, so the baby is unable to move by choice. It does move, but as I said, everything that's happening is involuntary. Okay, so the baby might be shaking its arm, but it's not controlling that shaking. The brain is, but the baby isn't consciously controlling that movement. Does that make sense? So you come back to school and get on with your life here. And in about 9 months' time, you go back home, visit the family. And now what you see is the picture on the right. Now we have an infant who can sit up, who can reach for a toy, who is probably self-locomoting in some form or other, right? Bum scooting or creeping. So this baby that couldn't move in just 9 months has turned into an infant who can voluntarily control quite a lot of skills already. Okay? So what this chapter is going to try to give us is some ideas of how that happened, right? What are some of the theories that try to explain this massive change in this individual over a relatively short period of time? Okay? So the first theory, the first approach, perspective that is introduced is called maturational perspective. This was really developed back in the 1930s, so a long time ago, all right? And it was an idea by a couple of researchers who were doing a lot of work, particularly with babies, called Giesel and McGraw, and they believe that motor development, so the changes that we see in the baby through infant and into toddler, etc., were driven by nature, by the maturation of the central nervous system and the peripheral nervous system. So what they believed was that the movements that they saw occurred because at that time that part of the nervous system had matured further. So for example, we'll be talking about the fact that we see a lot of stuff in the middle around the spine to begin with. We don't see much control in the fingers, right? It takes time before the fingers get involved. And so they were looking at this idea that it was really controlled by the central nervous system. So that genetics and hereditary played a large role in the motor development, in the motor patterns that we saw evolve. Okay? And they really didn't pay any attention to the environment that the child was developing in, right? So that's a big difference to our triangle idea, where we say the environment is one of the constraints that is interacting to create the movement pattern. Okay? So the only kind of impact they thought that the environment had was that it could speed up or slow down motor development, but it can't change the course of motor development. Okay? So they were looking at the qualitative changes that they saw occur. All right? And they thought that we had a sequence of development. So they had the same idea of the sequence, but that the sequence was invariable and it was genetically determined, right? So let's have a look. What do we think about that? Now, remember this was back in the 1930s. So, in this day and age, really, the maturation theory is one of the few theories where you would really say, they were missing the bigger picture there, right? We've changed our ideas quite a lot since the early 1900s. Okay, so the belief system that moved through really up until the 1970s was that our fundamental motor skills, our basic motor skills, emerge automatically. I don't have to do anything with this baby, with this child. They just will develop these motor skills, right? I don't have to work with them to help them. So, for example, if we use the throwing idea, I don't have to work with them to change them from stepping ipsilaterally to stepping contralaterally. It will just happen as the nervous system matures, okay? We know that isn't really the case now. Okay? So the rate may be individual, but the sequence is just going to occur, okay? Mild deprivation doesn't arrest development, doesn't change anything. And that the nervous system was the most important system for motor development, and other systems like the muscular system or the cardiovascular system or the skeletal system really didn't have very much significance at all in what they were watching happen with these children. Okay? So the key point of this, the problem with this idea, was that it really influenced PE degree plans for a very long time. So we have PE teachers and parents for many, many years who just think, oh, you know, I don't have to do anything. They will just throw a ball, right? Or catch a ball, or hit a ball, or run, or hop, right? I don't have to encourage that. I don't have to model that. I don't have to help that happen. Okay? So, that influence, although we now believe the maturation theory is too narrow, the influence that it has had on motor development and the understanding of motor development was long-reaching, right? So in the 70s, we have a new approach appear within the research. And this approach is called information processing, IP. And under this theory, the idea is that motor development is much more influenced, is driven by things external to the individual. So maturation theory was the nature, and information processing is more along the lines of the nurture. And so we started to have this argument going on between nature and nurture. Okay? So this perspective is the first real time we see a process-oriented approach to looking at motor skills, right? What's happening? Because the people that use information processing as a foundation for their research and their teaching believe that the brain acts like a computer, okay? That the human just responds to stimuli from the environment, from the external, right? And so we have these computer-type terms when we look at IP. We see input, encoding, processing, feedback. Okay? So I'm going to draw a very basic information processing model for you on the whiteboard here, if I can get this to... Now what happens if I stop sharing this? Do I have to reload it? This is going to be interesting. Let's see what happens. Oh, no, good. Okay, go back to the chat, go here, go to whiteboard. Okay, let me see if I can manage. It's going to be a little bit squiggly, guys, because my fine motor skills are extremely bad. Okay, so. Ooh. Oh gosh. So much easier on the real whiteboard. Okay, you can't get much more basic than this. Okay? So, how this works is that box 1 is the input. So it's the stimulus. That's not how you spell that word. Okay? So, for example, this could be a ball flying through the air, right? You see the ball, your eyes register the ball, they send that information to the brain. So that's the stimulus, the input. Okay? Box 2 is processing. Right? Processing, this is complicated. So box 2 is really the tricky part of this theory. Like, this is where all the work goes on in box 2. Okay? Because in box 2, processing involves recognizing the stimulus, right? Coding that stimulus. Really huge part of box 2 is the decision making, right? If I recognize the stimulus, now I've got to make a decision what I'm going to do about this stimulus. Okay? So decision making is a huge part of box 2. Once the decision is made, I have to pull out the correct motor program. So again, they're thinking along the lines of a computer program. So the computer has files, and now I've got to pick the right file to create the motor pattern for that decision that I made. Right? And then I have to start sending the motor pattern off to the body. All right? So box 2 is hugely complicated. Let's go back to the idea of the decision making. All right? If it's a ball coming at me, okay, then what do? Right? Am I going to catch it? Am I going to kick it? Am I going to head it? Am I going to step out of the way and let it keep going? Right? Lots of different decisions about what to do with this ball. So decision making can really slow things down. Right? It's one of the reasons why beginners are much slower than an expert at something, because the expert knows what to do. Right? And then box 3 is our output, right? So we've got our input, we've got our processing. Box 3 is our output, and that's the motor skill. Right? So this is the observable motor skill that occurs. That's the output. That's the result of the processing of that stimulus. Right? So in this model, then, the brain acts like a computer, a complex computer. So the central nervous system is considered the hardware, and the processes that are going on in the central nervous system are considered the software. Okay? Any questions? Think about this, because it does come up quite a lot in what we're going to be talking about during the semester. Okay, let me go back and see, hopefully that are good. That's good. Can you see the slide on information processing? I think you can. Okay. All right. So, unlike maturational theory, where we really don't consider maturational theory as a usable theory anymore for teaching or for research purposes, information processing is still very much a viable approach. So if you start reading around this subject, or for example, if you take a class with Dr. Gera called motor learning, right, then information processing will be talked about a lot under a motor learning umbrella, okay? So it's a very useful research tool, and you tend to find people who use information processing as their foundation, or people who use constraints theory as their foundation, okay? So when we're looking at these two, it's not a right or a wrong anymore. They're just different approaches to how I think a motor skill occurs. All right? So, under the kind of umbrella of information processing are several different theories under that approach. One looked at perceptual motor development, and this subfield was in the early 60s into the 70s. Really by the early 80s, this had kind of run out of steam. They were trying to link the idea that learning disabilities in children were because they had delayed perceptual motor development. So perceptual motor is the interaction between my perception of my environment and the motor skill that I produce in response to that perception. Okay? And so they were thinking along the lines that if children's fine motor skills were delayed, that might be because there was a problem with them interpreting what they were seeing on the chalkboard in the classroom, for example, right? By the 70s, we were really looking at the development of sensory and perceptual abilities under this IP umbrella. And so now the information that we have, and we will be looking a little bit more deeply at perception action in the future. Much of our understanding of perception action, and so a lot of the work in that chapter when we get there, comes from IP, from information processing approach to research. All right. So we're going to get a little bit of both types of theories, okay, as we move forward. Okay, let's do one more slide and then we'll take a couple of minutes break, because I want to be disciplined about keeping this break in this class, because it's a long class to sit and try to concentrate. Okay, our third perspective, our third approach in this chapter is the ecological perspective. And this is the approach that our constraints theory sits under. All right, this is the umbrella where our constraints will fit. So the ecological perspective really started coming into its own in the 80s, once you get to the mid-80s, which is why I did not get this, because I had graduated undergrad. When I was in undergrad, everything we did was information processing umbrella, right? Lots of different items that fit under that umbrella, subfields. So I didn't get anything about ecological theory until way later in my career. So, ecological approach is trying to describe and explain and predict motor development, all right? And we come back to the idea that multiple systems within the body are important, and that there's going to be interaction and interrelationship between the individual, the environment, and the task that they're trying to achieve. So the development of movement comes from this interaction, right? And so here, as opposed to maturation approach, the neural system, the nervous system, is only one of many systems that impacts motor development. Right? And what we see when we think about it this way is that at certain times across the lifespan, one system may have more influence than another system, but they're all working together, right? So for example, when children hit puberty, the skeletal system goes berserk, right? Almost overnight. And we see these big, quick changes in leg length and arm length, right? So at that point in time, the skeletal system is having much more influence over the movement pattern that we observe than maybe some of the other systems. But then it changes because then the muscular system has to come in to control all these bones that are now way longer than they were before. Okay? So we're looking at all the systems working together. Okay? It's an interplay of many constraints. How I move isn't just the environment I'm in. It's not just the task that I'm given, but my body, my mind, right? Lots of different relationships going on there, okay? So, under ecological perspective, we have two major branches. One is dynamical systems, which is where constraints theory came from, and the other branch is perception action, which is a little more linked to some ideas from information processing, right? But the main difference between information processing approaches and an ecological perspective is that under IP, remember we have a central governor. The brain makes a decision and picks a motor pattern and directs that motor pattern out to the body. Okay? Under an ecological perspective, we say that perception is direct, that all the systems are working together, that the environment changes and the motor skill changes, and that we're self-assembling in response to all these different constraints that are interacting. Okay? So it's a different way of explaining the motor pattern that I observe at the end of the process. Okay? Again, it's not a right or a wrong, it's just different. Okay? Okay, so let's take 5 minutes. Where are we? It's 10:07, right? So we'll come back at 12 minutes past 10 and we will tackle the next couple of slides. And I've got a piece of video to show you that hopefully will help with these ideas. Okay, so I'll see you in 5 minutes. I'm going to do a quick bomb around the building because I can't be in this room for an hour and a half. I'll remember to take my keys this time.
Yeah.
Do you need them for anything?
No.
Okay. in time. Oh no, I'm 2 minutes late. Oh, 2 minutes late. I went around the outside of Greyhound Arena. I had to get some fresh air. I'm going to have to start running now. Walking apparently isn't working. Okay, where did we get to? Let's put this back on. It's cold in here. All right. So, my plan now is to give you a brief look at dynamical systems so that you can see how constraints theory kind of came out of that original idea, and then show you a bit of film, and then we'll cover the perception action information on Thursday before we start chapter 3. Okay? Okay, so as I mentioned last week, dynamical systems theory originated, I believe, in the field of astrophysics. Something hugely complicated anyway. And then it was kind of borrowed by different fields of study. People looked at the idea, and if you want, I was playing around in YouTube this morning. If you want to look at a more mathematical model of dynamical systems, there are some really cool animations and little bits of film out there on YouTube that would help you with that. I'm going to stick with a simpler version, okay? I don't want to get into the details of the mathematical model. So, in the early 80s, the idea of dynamical systems found its way into motor behavior, specifically motor development. And Kugler, Kelso, and Turvey were the first group of researchers that really said, wow, you know, we could use this idea and apply it to movement. And what they thought about was that our body systems, so my muscular system, my skeletal system, my cardiovascular system, spontaneously self-organize given a set of constraints, all right? And that it doesn't necessarily need the involvement of the central nervous system for a new movement pattern to emerge, okay? So our movement patterns then aren't driven solely by the central nervous system. And this was the first time that that idea had come into fruition within motor development. It was really the beginning of motor development, I think, because up until then we'd had this very, central governor, brain-oriented approach, and that was very much more looking at motor learning concepts. What was the brain doing? So again, we have this idea that the body systems, the individual, the performer's environment, and the task demands all get to interact, and that movement pattern emerges from that interaction. Okay. So this idea then of spontaneous self-organization means that many of my motor skills are soft-wired, not hardwired. So when we use those terms and we're looking at an ecological approach, hardwired skills are those that have a very, very strong genetic component to them. So, for example, if you're a typically developing human, you will stand up on two legs and walk on two legs, right? That's not to say that all humans do that, but if you're typical, if everything is healthy, right? So that would be considered a hardwired skill, okay? Not everybody walks exactly the same, so it's not completely governed by this hardwiring, but everybody will do that. But other skills like throwing, catching, skipping, and our sports skills and life activity skills are soft-wired under this approach, right? Whether I do them or not is somewhat affected by the environment I grew up in, right? So if they were hardwired, I would see them regardless of the environment I grew up in. But that's not the case, okay? So I want to introduce a term that you'll see in the book that plays quite a big role here, all right? And that term is a rate limiter. In some textbooks it's called a rate controller. In our book they call it a rate limiter, all right? Rate limiters are individual constraints, okay? And a rate limiter is either the system that developed last during a growth period that impacts a certain skill, so it limits the emergence of a particular skill. Or, when we go to the other end of our lifespan, it's the system that declines to a critical point first during aging, and that accelerates change within that motor skill, generally downwards. Right? So, the slowest system might be the particular system that allows a certain movement to occur. Right? So, for example, my legs are strong enough for me to learn to stand up and walk. But if I want to hop, now I have strength in the hopping leg. I've got balance, which involves the vestibular system, right? I've got comprehension of hopping up and down or hopping forwards. And I've got some control going on as to which muscles and how much body lean I have as to whether I go up and down or forwards. Right? So there's lots of systems involved in the change to hopping. And it's likely that one of those systems acts as a rate limiter, probably either strength or the vestibular system. Okay? At the other end of the lifespan, the skeletal system could be the rate limiter, right? I develop arthritis in my hip socket, and so my walking pattern changes dramatically because of the arthritis. example. Right? So the idea of a rate limiter is quite important when we're looking at these systems interacting to produce a movement pattern. Okay. And then one of the diagrams in the book, you may or may not find this helpful, okay? If you're good with graphs and things, this set of diagrams may be very helpful for you. If you're not so good with graphs, you don't have to worry about it, all right? It's just a tool to help you understand this idea of the interacting systems within the individual, okay? This won't be on an exam. It's the concept of the interaction that you really want to take away, all right? So, if this helps, great. What this is trying to represent is different systems within the body. So system 1 at this point in time isn't changing, could be the cardiovascular system, right? System 2 wasn't changing, then had a nice sharp improvement and then isn't changing at the moment. So that could be maybe the muscular system, right? System 3 wasn't changing, did some slower change, and now it's not changing again. So that might be the peripheral nervous system, right? System 4, we're seeing a different pattern completely, right? And the idea is that the behavior we see is a combination of all of these working together. Okay? The maturationists would have said the only rate limiter was the central nervous system. Right? As I say, we don't really, it was useful at the time, but it's not something we use now. Questions? No questions? Okay, let me stop sharing this. Let's hope this sharing thing works. Go over here and make sure I've got that. Okay. We are going to share YouTube. That one. Okay, that's good. You can see the YouTube. All right, let me go back and play that. Here we go.
Learning and improving a skill involves perfecting certain motor patterns, which can be difficult for different people. Dynamic systems theory explains how individuals adapt to the integration of systems cooperatively functioning together to meet the environmental, task, and individual demands. Dynamic systems theory is a broad theory which is complex, nonlinear, and self-organized. Task constraints are rules, goals, or equipment used to perform a specific task. As demonstrated here, Liam is performing a bodyweight squat. His squat is slow, controlled, body upright, and feet stationary. What if catching the football is added? Although Liam is still squatting, his squat is no longer stationary or controlled as he moves to the location of the football. This is a constraint many football players experience in the weight room versus practice or at home. slightly off balance and feet not staying planted. Let's add some weight and see what happens. When compared to his body weight squats, with the addition of weight, Mike is able to not only stay balanced, but his body is more upright and his squat is lower. Environmental constraints are changes in a person's physical surrounding and are constantly changing. As Trevor performs a bodyweight squat on a football turf with nothing but the sun and a light cool breeze around him, he is able to execute a perfectly controlled squat. However, when you add the unstable platform of a mercy ball, an unexpected poke of a crutch, Trevor's squat becomes slower and requires his body to adjust differently to balance each time. In conclusion, dynamic systems can be seen in all aspects of our life, whether it's walking to class, lifting at recreation centers, or running routes in football. Some changes are obvious and others subtle. The key component is that our bodies are adapting motor behavior changes through series of individual, environmental, and task constraints.
Okay. All right. Now, I don't know why. Didn't come up there. Okay, so I hope that helped a little bit. Very kind of using a skill we all know quite well and using that to explain how the different constraints interact to change the motor pattern, I thought was hopefully useful, was my plan. Any questions now? I really recommend that you take the time to go back to the chapter in the book, look at it a little more thoroughly, in your own time, under your own speed. Maybe go to the website and look at the activities that they have there connected to this, see if any of those help with your understanding of these ideas. All right? And then, as I said, on Thursday, we'll look at perception action, and then we'll start chapter 3, which is a very brief introduction to some biomechanical principles that play a big role in motor development. So if you've already taken HPE 312, chapter 3 should be some review for you. And if you haven't taken HPE 312, chapter 3 will be a good foundation for taking into 312. Okay, so I don't have any office hours today. I've got heaps of paperwork to do today. So if you need me today, drop me an email or a discussion board. I do have office hours tomorrow afternoon. If once this has soaked in, you've got some specific questions that you would like to ask and get me to explain for you. Okay? All right. Bye.